Hey guys, welcome back to my channel. Today we'll be solving this question, the integral of sine inverse of root x, and we'll be solving it by parts. And we'll also use the substitution rule. So let's begin. So if I keep x as t square, or rather root of x as t, dt by dx is actually 2t dt by dx. It becomes 1 because I'm differentiating both sides with respect to x. So dx becomes 2t dt because 1 into dx is dx. So 2t dt becomes dx. And now I'll show you the Lie rule because we are integrating by parts. So the Lie rule helps us to decide which term of the integral we should keep as u and which term we should keep as v in the by parts formula. The by parts formula is u into the integration of v dx minus the integration of differentiation of u into the integration of v dx. So the Lie rule helps us to decide which term we should keep as the first term, that is the u term, based on which term of the integral is easier to integrate and which term of the integral is easier to differentiate. So here we have two terms. First of all, let's replace t in the integral so then I can show you which are the two terms. So we would have sine inverse of t into, we'll also have to replace dx by 2t dt. I can take 2 outside as my constant, but I won't do that now because that will help us later in the by parts formula. I'll show you how. But first of all, I'm going to write the integral as 2t sine inverse t of dt. So my first term becomes 2t and my second term becomes sine inverse t. But now we have to decide which term we have to keep as u, that is the first term of the by parts rule, and which term to keep as v. So 2t is basically an algebraic term because we have t raised to 1 and we have an inverse trigonometric term which is sine inverse t. Now inverse trigonometric comes after algebraic, which means that inverse trigonometric should be selected as the first term because Lie is the order of preference for the first term, that is the u term. So I'll keep the inverse trigonometric term as u and the algebraic term as v because algebraic comes after inverse trigonometric. Now we have u, that is sine inverse t, into the integration of v, that is 2t, minus the integration of differentiation of sine inverse t into the integration of v. So now we know that when we differentiate t square, we get 2t, which is why the integration of 2t is t square. But if you want another justification, if I keep 2 outside as my constant and I integrate t, then we know that the integration of t raised to n dt would be t raised to n plus 1 upon n plus 1. So the integration of 2 integral t would be t raised to 1 plus 1 upon 1 plus 1, which is 2t square by 2, and the 2's will get cancelled, which is t square itself. So we have t square sine inverse t minus the integration of, we know that the differentiation of sine inverse t is 1 upon root 1 minus x square, and the integration of 2t is t square. Sorry, I meant to keep this as t dt. So now I'll use the substitution rule again over here. So I have t square sine inverse t minus the integration of t upon root 1 minus t square dt. So if I keep 1 minus t square as p, so dp by dt becomes minus 2t and dt becomes dp upon minus 2t. So if I multiply and divide 2, I can cancel these terms out. Let's see how. T square sine inverse t minus, I can keep 1 by 2 outside. So I have the integral of 2t root 1 minus t square into dp upon minus 2t This 2 get cancelled and I can take minus 1 outside and make this a plus sign. So we have t square sine inverse t, and this 1 minus t square we have to replace by p. So plus 1 by 2 into the integration of dp upon root p. Now 1 upon root p is basically 1 upon p raised to half, which is p raised to minus half. I can take this in the numerator and raise it to a negative term. So now we have t square sine inverse t plus half integral of p raised to minus half. And we know that the integral of p raised to n would be p raised to n plus 1 upon n plus 1. So the integration of p raised to minus half is p raised to minus half plus 1 upon minus half plus 1. So this is basically p raised to half upon half. P raised to half upon half is basically 2 root p, and p was 1 minus t square. And remember that t was root x. So now we're going to take everything in the terms of x. So t is root x and p is 1 minus root x square, which is 1 minus x. So we have root x square sine inverse root x plus half into 2 root 1 minus x. 2 and 2 gets cancelled and root x square becomes x sine inverse root x plus root 1 minus x plus c. And this is the final answer. So that's it for today, guys. Thank you so much for watching. I'll see you in the next video. Bye.